Welcome to the Immutable Labs AI podcast, where we deep dive into the latest innovations in technology and their impact on our world. I'm your host, Iris Duan, and COO of Immutable Labs, and today we're joined by a very special guest, Farhan Mallick, our in-house researcher in the artificial intelligence leading text and video initiative space. Farhan, it's great to have you with us today in today's discussion of OpenAI's SORA world-building technology.
Thank you so much, Iris. It's a pleasure to be here with you.
So let's start out with the technicals. Could you explain the basics of how SORA works?
Yeah, the SORA paper, it shows why OpenAI are so effective. They don't invent anything new, they simply build on the previous research that are available open source and they integrate them. Well, the basic formula to make things working that OpenAI absolutely gets right is they pick up the best data, they pick up the already proven models, and they scale it. Well, Sora is a testament of what can evolve out of multiple models and system working together. They're bringing hybrid models together and they're winning in it. The videos that you get out of Sora, they are quite similar to what you get out of in Midjourney. The images in Midjourney, they're very similar to the videos that you get out in Sora. Well, which basically means that they already have the state of the art data, if not better. Data, it is the key magic because the architecture that they're using in Sora, it's not too novel.
Mm-hmm. Okay, that's really interesting. You mentioned the architecture. What is the architecture behind it?
Uh-huh. Well, the architecture behind this is diffusion on transformers. Uh, it's basically a diffusion model that's running on a transformer backbone. It consists of a VA encoder, a VIT, a DDPM, and a VA decoder.
Okay.
That's the mixture of all of this is what they're using here.
Let's break that down maybe piece by piece. Let's start with the VAE. What is that?
VA stands for variation autoencoders. It basically creates a linear embedding of an image so that we can feed it further to the transformers.
Mm-hmm. So the neural network understands numbers. So if there's a way that we can make numbers out of images, neural networks can work on them. And so that's what the encoder does, if that's correct.
Yeah, that's exactly right. That is exactly right. It converts it into a matrix that's understandable by the neural network. So neural network can further process it. You cannot feed images into neural network. You must have to speak their language. That is what it does. That is what a VA does. That's absolutely right, Iris.
Yeah, so it converts the images into numbers and then it flattens them. And then I assume that the decoder turns it from numbers back into images.
That's right.
Okay, yeah. So the you mentioned DDPM. What's that?
DDPM, it stands for denoising diffusion probabilistic models, which basically predicts noises instead of the individual pixels. Units, they are the usual choice, but then Sora, they're using a transformer based backbone architecture instead. DDPM takes up a random noise and then it keeps subtracting little noise from it until we get an image.
Okay, that's interesting. So the DDPM focuses on figuring out how to clean up the noise bit by bit until only the original picture is left.
Exactly. And that is like so much better than calculating the probability on individual pixels. It's so much faster than that. That is
And
what's been used in stable diffusion. Yeah,
so that's what unit does, is that it does pixels by pixels.
it does pixel by pixel. Yeah.
Okay. So you mentioned VIT, which is the vision transformer. Can you tell me a little bit about that?
Yeah, for sure. Uh, well, to explain VIT, I have to bring in the whole context of it. There was this research paper that they released on Archive. It was called Image is Worth a 16 into 16 Words by Alexei et al.
Hmm.
So basically, what it proposed was instead of going to the individual pixel level of an image, they're just going to slice it up in patches. like small square patches out of that whole images, and instead of doing processing with the individual pixels, we process these patches instead. So a VIT uses those patches, it splits the image and it creates linear embeddings of these patches, and that is what it transfers the transformers to. It transfers those linear embeddings into the transformers, and the transformer does its thing and it considers the relationship between those patches, and it outputs linear embeddings for each patch. These embeddings, they represent image in lower dimension. That is what VIT does.
Interesting. So the vision transformer finds the most probable output by identifying context, which is like the patch when it's given a lot of data, right?
Exactly. That's absolutely right.
Okay, so why are they using vision transformers instead of normal transformers?
Well, Vision Transformer, it has less image specific bias, and then it's pretty fast in learning the relationship between the patches from scratch. And then it uses the attention mechanism and it captures the long range dependencies in the context of the image. That is why they're using VITs instead of normal transformers.
Okay, interesting. So now that we've gone into all the nitty-gritty, can you summarize all of this architecture at a high level? What does all this mean?
Hmm. Well, basically, instead of computing the relationship between the individual pixels in an image using transformers, because individual pixels are like too many numbers and it gets too costly in terms of computing power, what OpenAI did is it divided those images into patches, into portions, and it turned those portions into sets of numbers. And then with all the compute power that they had, all the GPUs that they have stored, they went all in and they computed the relationship between these sets of numbers. And then they put all of these probabilities in a matrix, they put it together, and they called it a SORA.
Okay, so what is the key problem that this solves?
Well, two things. It reduces the compute power by a considerable margin because you're not dealing with pixels anymore. You're just dealing with patches, a part of the image. And it performs as well as a model trained on individual pixels. So why uh, give out the compute power, and why not scale it a bit more when you can? That is the problem that it solves.
Yeah, so by using larger building blocks, these patches instead of pixel by pixel, it's faster, more efficient, and reducing compute power. That's so
Yeah,
interesting.
and then you can pull out more models and more probabilities by using the same amount of compute power.
Yeah, you can do more with less. That's really, really efficient. Let's
Hmm.
compare this with stable diffusion. Can you maybe compare and contrast?
Yeah, stable diffusion. It uses a unit. Well, VIT is more flexible for input data. It processes the visible patches and it ignores the masked one because it doesn't have to deal with individual pixels anymore. And most of the pixels in images are irrelevant. You just
What are
have to
visible
focus on
patches
what your
and not?
subject is. And that is where VIT kicks in. That is why VIT is better, and that is why OpenAI is able to generate such good videos out of it.
What are visible patches and masked patches?
For instance, suppose you have a picture, a duck in a pond,
Hmm.
and then some users comes by and they want a duck in their bucket instead. So
Okay.
VIT, instead of looking at the individual pixels, it would just look at the patch where the duck is. Because in the first picture, the pond is irrelevant. It's a
Oh.
masked layer. So you need to concentrate simply on the duck. You need to pull that duck out, and then you need to put a different background in there. So you just have to
Hmm.
like process the part where the duck is instead of processing the rest of the image.
Hmm.
So that is where it shines.
I see, I see.
And then Sora can control the size of generated videos by randomly arranging initialized patches in an appropriately sized grid. Unit does not offer this flexibility. When we are slicing the images into different patches, what VIT does, it gives them a number. Every
Hmm.
patch has a number. So you can figure out by these numbers where these patches are. You can figure out their positions by the numbers. It's what we do in coordinate geometry.
Oh,
So we have the positional context of it. That is like really important. So
mm-hmm.
we have more context and we know what to focus on. That
Oh,
is where it shines as compared to stable diffusion, which is using individual pixels.
right. So not pixel by pixel, just the duck highlighted in the pond.
Yeah, exactly.
Okay. So what about scalability? Can you maybe elaborate a bit on that?
Yeah, optimized DIT, it runs much more faster than Unit. Unit is the architect in stable diffusion, by the way.
Mm-hmm.
And SORA, it demonstrates that DIT scales very well, both in case of photos as well as videos. And then it is even found out that the architecture can figure out physics on its own without having a dedicated physics engine. So it can build up, it can connect the dots, and it can figure out which dots are important and which dots are applied in every videos. That's how it figured out physics, and this is like such a big milestone.
Right, because there's still some problems. I remember when they released, for example, the cup with the ice falling on the table. The
Yeah,
physics isn't exact, but it's much better than anything else that's out there.
it's much better, yeah, and it did that without a dedicated physics engine. That is like such a big thing in AI itself.
Mhm.
Uh, if we had to do this in our Metex lab, in our own workstations that we have to use a dedicated physics engine, a control net which tells the stable diffusion, oh, these are the laws of the physics. This is how you're going to follow it. And OpenAI, its Sora model, it did all of that on its own. It's a data-driven physics engine.
That is so crazy. Wow, that's really impressive. Wow, so that's a lot of information about the data architecture and the model. Let's pivot to talking prompt engineering about taking inputs from the user side.
Well, Sora, it's multimodal on both sides. It's multimodal both on the architecture and both on the prompt side of it. What I mean to say is, OpenAI, it already has two state-of-the-art tools. It has DALL-E 3 and it
Yeah,
has ChatGPT 4, and we have all used it and we know how amazing it is.
absolutely.
So they're using DALL-E 3 to generate high quality textual descriptions from each frame of the video. So they have like a lot of data, a lot of video data, and now they need someone to write things about those data, those videos to feed into the transformer models. And that's where they're using DALL-E 3 for.
Mhm.
And on the user side of the things, they're using ChatGPT 4 to enrich and expand the prompts it take from user. They're not using the vanilla prompt that the user puts in. No, they're not doing that. They're
Right.
putting that prompt into ChatGPT 4 and they're expanding it.
Mhm.
That's what they're doing.
Wow, that's really interesting. So instead of like, oh, a mermaid is riding on a dragon, it's like the year is 2000 and there's like a beautiful purple-haired mermaid who just fell out of the water. Like, like all these other kind.
Exactly. It's much more flowery. The language is so very uh, concise and well, it's pretty flowery. It's more than what we could imagine and what we could type. So that is how they're enriching it with ChatGPT 4.
Interesting. So it knows what you want.
Yeah, exactly. It knows more than what you want.
Exactly.
It's
Yeah. Before
yeah,
you
that's
even.
that.
All right, let's get into some more speculative discussions. Can you talk maybe a little bit about the data that OpenAI trained the model upon?
Hmm. The research web page that the OpenAI released, it has like a lot of gray areas in it. There are things that they want to hide, and it's pretty
Right.
much evident from what they released. The fact that OpenAI doesn't talk at all about their data quality in their technical report, it simply implies that the data quality must be the most important factor for the success of Sora.
Mhm.
Look, we had latent diffusion on transformers up on the open source, and people have tried it, and it wasn't that good. It wasn't as good as OpenAI's model is. So there must be some secret sauce to it, and that secret sauce is the data. People in the Twitter are speculating that they might be using Unreal Engine 5 and they came across a hack to generate lots and lots of videos and then they captioned that video. So this
Right.
they left like a lot of gap for people to speculate.
Absolutely. There was also another tweet by a thought leader, I think his name was Pierre, about how he plugged in all of the prompts into another model and they generated very similar static images.
Well, that simply implies that they have the state-of-the-art data, if not better.
Mm-hmm. Wow. So, how much of the video is just approximate retrieval from a secret data set that combines high quality cinema scenes, game engine data, as we saw with the Minecraft and Unreal Engine 5 speculations, rather than generation?
I mean, we don't know that yet. It might
Right.
just be that OpenAI is using a RAG and it's retrieving some of those patches or some of the information of the patches, and then it's just closing the gaps with their VITs. It might be that, but then we are not too sure. Um, this is the gray area that
Right.
OpenAI wants people to talk to.
Yeah, so this is
And
what the entire internet is buzzing about is we really don't know the answer to
exactly. And it gives us a lot of questions. I mean, I had like a certain question in my mind as well, but then
hmm
you don't have anything to answer to cater that curiosity of yours.
Right.
Uh,
That's so interesting. So, what are your overall thoughts on this Sora approach?
Sora mainly it uses the better data with a simple architecture and then they're scaling it. Uh, a lot of research has been done on the same, and they didn't get results as good as OpenAI, so they must be doing something very right that they don't want people to find out.
Oh, don't want people to find out. This sounds like Sora is not only just a technological marvel, but also a potential catalyst for discussions around the ethics and future of AI and content creation.
It's just that we might be sitting on an ethical nightmare for government agencies. And this can go a lot of ways. I mean, the worst that we can imagine is government forcing them to shut down, or they're forcing them to put a watermark or something on the whole
Right.
thing.
And even if they do that to OpenAI, there's going to be a lot of competitors that rise up and maybe don't follow the prescribed regulation.
Exactly.
Really don't know.
We don't know where it's going from here. The moment they release it on the web for public to use it,
Mm,
it's the sky is the limit, yeah.
Yeah, sky's the limit. So it's over for Hollywood, huh? Maybe not.
Well, not at this moment, but then maybe 5 years from now, yeah, it's completely over for Hollywood. Well, I'm just wondering how long until public finds this boring and trivial.
Yeah, who knows? Maybe Disney or Universal will start making custom endings to the end of their movies. What if Jack lives in the Titanic?
That is such a fun thing to imagine. I mean, if this ain't worth 7 trillion, then I don't know what is.
Right? Yeah, it's incredible to think about. I mean, just a few months ago, creating an image of an animal riding a bicycle was a challenge for AI, and now we're talking full-blown video generation.
Dude, absolutely. The video that they released on Twitter and all those spaces, it's almost like you have took like 5 mg melatonin and you went to sleep, and this is the dream that you're having.
hmm Well, I'm praying for all the film school students right now, but hopefully this will manifest itself as a job tool and not a job killer. Farhan,
Well,
this
yeah, I
has
hope
been,
so.
yeah. Well, Farhan, this has been an enlightening conversation. Sora is undoubtedly a fascinating project, and we can't wait to see how it evolves. Thank you for sharing your insights with us today.
Yeah, thank you so much, Iris.
Yeah. To our listeners, thank you for tuning in to the Immutable Labs podcast. Don't forget to subscribe for more discussions on the cutting edge of technology and innovation. Until next time, stay curious and stay skeptical.